We are going to launch the class, mechanical class from the Google model, as you can see from the screen. So we have live classes here. I've already set the link to the students. We wait for them to join. Hmm? So we are having the so you can see we have a quorum in a class. So let's continue waiting for others to join. So we have more. Yes. So kindly make sure you mute your mic so that at least we can be able to hear from each other as well. So we are almost starting. Kindly be patient. So in today's class, we are going to check on strength of materials. And I'll start this session by welcoming all of you to the class. I hope you can hear me well. Can you hear me? Kenodia, can you hear me? Good. Victoria, can you hear me? Yes, at least I can see most of you. You can be able to hear me. So if you can see from the screen, we are going to check on the strength of materials. And kindly make sure by the end of the class you do all your assignments. And also make sure you attend your classes on time. So by end of this session, I would expect you guys to be able to define what forces and also state its units and also describe tensile force, state the relevant practical examples, describe compression forces and state relevant practical examples also. And also you describe what are shear forces and state the relevant and practical examples. Then lastly, I will expect you to be able to calculate mechanical stress and evaluate the failures associated with it. So this session, we are going to have an online session for 8 to 10 minutes. And then after that, you will be able to watch the videos on your own, which I shall be uploaded on the platform. And then after that, you are going to do assignment and submit it as indicated on the course outline on the module. So we start by a definition of a force. Who can tell us what a force is? Anyone? Yes. So a force, we can say a force is a pull or a push, and anything that can influence a change in the state of an object. As you can see from your screen there, you have somebody pulling something. That we call that force. You also have a compression forces whereby you compress something, and also when you try to twist something, it can break, as you can see from the photos indicated on the screen. So the effect of forces on mechanical object, they cause a mechanical object to bend, to twist or break. And also a force can make an object to change in motion, as you can see from your screen. So somebody is making noise. Kindly mute your mics, as we said earlier. So three types of mechanical forces. We have tensile force. These forces tend to stretch a material. An example is a cable of a crane carrying a load. We say it is in tension, as you can see. Rubber bands, when stressed, we say it is in tension, as you can see from the figures on your screen. Also, we say when you are tightening a nut, then it is under tension. So second, we look at compression force, and we say a compression force is a force that tends to squeeze or crush a material. An example is a pillar which hold on a bridge. You can be able to see that. So Moses, can you mute? Kindly please. We can hear a lot of background noises. Thank you for muting. So as I was talking about the compression force, we said one is a pillar holding a bridge. We say it is under compression forces because when the car and the weight of the bridge apply forces on it, then we say it is under compression force. Even you, when you are walking on your shoes, you see the sole of your shoes is under compression forces, and there are very many examples whereby you can have a compression force. So a shear force, this one is a force that tends to slide one phase of a material of an adjacent phase. And the example is a rivet holding two plates together. We say it is in a shear force. So as you can see from the diagram figure 1.3, that rivet, you say those two plates are under shear force. So also when you are using a garroting to cut a material, maybe a sheet of paper or a metal, you expose it to shear force, and that's why it can be able to cut. Also, a transmission joint on cars are subject to shear forces, as you can see that. So in our objective number 4, we said about stress, and we say stress is a force over area, as you can see on your screens. So for example, we say if a rectangular bar has a cross-section area of 75 millimeter, and a tensile force is applied on it by 15 or 15 kilonewton, then when you are determining the force or the stress, we just divide force over cross-section area, as you can see that. So it is quite easy for you to look for stress. What you just need to know is measure the amount of force applied, and then you measure if the cross-section area of that object by which the force is applied, and then you can be able to know the stress. And the SI unit of stress, we call them megapascal or Newton per meter squared. So, having said that, at least uh, at least for now, you can be able to calculate what a stress is. So I would like you to do an exercise here. You have an exercise here which is on your screen. Kindly make sure you do it in your group, and also I will ask you to post your answer later on the chat box so that I can see who is correct and who is wrong, or if you are attentive in the class. And also, in your normal groups, I also want you guys to watch the video, which I have inserted some there, a link there. Kindly make sure you watch that video in groups and also be able to answer this question. And that's a group assignment. Individual assignment, you have that question which is there. Kindly make sure you do that. And also, in order for you to get extra materials to read it, follow that link attached on the screen. And then that's all we have for today. And make sure next week you'll be ready for the class on time. And make sure also you submit those assignments on time. Thank you for joining my class and have a great evening. Any question before? Thank you. All you got well. Enjoy your day. Asanteni sana.